Awesome. All right. Hi, everyone. I want to thank you for joining us this afternoon and spending the next hour with us learning about email. And if you are here to learn about email, you're in the right place. If you're not, then you might have gotten your rooms mixed up. This is the whys and hows of integrating Amazon SES into your product or website. My name is Chris Wheeler. I'm the Senior Technical Program Manager for Amazon Simple Email Service. I've been with the service since it launched last year. And I want you to take away three important aspects today from this presentation. The first is I want you to understand the complexities around sending email. The second, the fight against spam and how that impacts your daily job if you're trying to send email. And the third, how you can use Amazon Simple Email Service with your application or website. And so we're going to go through a demo later on, and we'll leave you with a few steps at the end of the presentation so you can easily get started using it. So I'm going to start off with a little bit of a cheesy question to the audience. Pretty rhetorical, but who in here is familiar with email? Good. How many of you have sent an email in the last 2 hours? Exactly. How many of you have set up your own email program before? Outbound email sending solution. All right, and how many of you had a great time, no problems, it was a complete success? One person. All right, you're in the wrong room. So let's just go back to the beginning and discuss a little bit about why sending email is hard. We all know what email is. It's just, a decades-old technology, been around for a while, very mature. But there are a lot of problems associated with it, and a lot of problems that are masked from end recipients and you as a sender unless you've actually tried setting up your email program before. And we're going to go into those different areas today. So the first is your DNS settings. Do you have an A record set up? Do you have a PTR record set up? Do you have an MX record set up? Is your reverse DNS also synced with your forward DNS? Chances are, if any of this is foreign to you, then you probably haven't faced this before, but ISPs are looking for all of this. And when I say ISP, I mean email receiver. So we're talking about Yahoo, Gmail, AOL, or the B2B folks out there, so your own corporate domain that you receive email at, or I receive at Amazon.com for my personal mail. Second is IP seasoning. So an IP address is in all, basically when you're sending email, it's the one immutable data point that an ISP looks at and assigns an identity to. Everything else can be spoofed, but an IP address can't. And so IP seasoning is where you actually send mail over an IP for a specified period of days, change your algorithm depending on what ISPs you're trying to send to, and it's analogous to a FICO score. ISPs learn to trust you over time because you've sent high-quality mail and higher volumes over time, so on and so forth. If you try to spin up a brand new IP today and push a whole bunch of mail through it, most of it's, if not all of it's, going to get dropped on the floor, bounced, blocked, all that good stuff. DKIM. So this is Domain Keys Identified Mail. It's a cryptographic authentication protocol. It was developed by Yahoo a few years ago, and it's become the de facto authentication protocol in the industry. It basically takes a message, a hash of the content in the message, including or excluding some headers. You have a public key, private key pair. You sign with a private key. You issue your public key and your DNS. The ISP looks at it upon receipt, looks it up, and says, OK, the person who says that they're sending this message actually has a valid signature. And in this day and age, with so much phishing going on, it's really becoming more of an expectation from ISPs if you're trying to get mail delivered. Next one is special servers. So what I mean by this is there are software and hardware servers that are specially designed to send email. Everyone's heard of Postfix or XM. There are also commercial products available as well. Some come shipped on a server, some don't. You install them yourself. But the moral here is these servers are set up with special configurations to pump high mail on an outbound basis, opening up SMTP connections with the receiving MTA, pushing through messages per connection, handling retries, making sure they're reading error codes correctly, which of course they're not consistent depending on which ISP you're dealing with, and all that fun stuff. ISP throttling. So this is where you have a Yahoo or Gmail or AOL, et cetera, they push back on your mail. So if you're sending mail into that domain, and let's say you're sending it too quickly, or you haven't sent enough recently, or your mail is, however, deemed low quality, the ISP will engage in throttling. And they can issue soft bounces, they can issue hard bounces, they can just accept your mail and queue it for delivery later. You might have had recipients before where they're like, I never got my mail, and you check your mail logs, and you're like, well, I sent it yesterday. The ISP in that case might just be holding on to it. Recipient response. A couple of years ago, if you looked at the spam landscape and the defenses that the ISPs were putting up, they basically, and there's some outliers here, but basically they looked at a few different things. They said, how many times are messages bouncing that you as a sender are sending out? How many times are folks complaining about it? And does it pass some sort of Bayesian content filtering scheme? Beyond that, they were like, this is pretty good. Over time, though, there's so much mail flowing through mailboxes or trying to get into inboxes around the world that ISPs have really cracked down on figuring out what the user engagement is with that message. And user engagement is analogous with recipient response. Are people opening your messages? Are they deleting them without opening them? Are they moving them to the spam folder? Are they moving them to other folders, never to be looked at again? And then they build a profile for each recipient, and then they add all those profiles together, and then they create your sender profile out of that. And if you don't have a good profile, your mail doesn't have a good chance of being delivered. Spam. Unfortunately, you guys are fighting something that the spammers have been doing for a while now. They're making really good money at it. There are regimes, depending on what part of the world you're looking at, whether it's someone just doing it for fun or to actually cash in. And the ISPs have had to be very good about defending mailboxes from spam. And you're up against those same defenses. Deliverability. You might have heard this term before, but this basically describes what are the chances of your email message being delivered to the inbox. And I would imagine each one of you have email as a component of your application or your service, or it somehow fits into your program. Email is ubiquitous. But if you never expected the message to be seen by anyone, or a machine, or get to any mailbox destination, you wouldn't be sending it in the first place, right? So deliverability is figuring out how many messages are going to the spam folder versus the inbox and making sure that you're not on any blacklists out there. Spamhaus hasn't listed you. Your URLs aren't showing up any of these special blacklists. You're on whitelists where available. Complaints. So this is, if you go into, and they have local clients and also web clients, if you look at the This is Spam button when you check your mail, or some of them have like a little flame icon, and you select a message and you click that, message goes away, you don't see it again. Some ISPs block those messages from ever going to your inbox again. But behind the scenes, what's happening is the ISP is taking that vote and saying, all right, someone has said that this message is low quality. And as those complaints add up over time, it creates a picture of you, going back to the IP address that we were talking about, and the ISP might determine, hey, you actually look like you're a low quality sender, as voiced by our recipients who are getting the mail. And remember, nowadays, ISPs have really started erring on the side of listening to recipients. And so you can get into semantic debates over, well, my mail isn't low quality, and it's really useful. But at the end of the day, it really matters what the recipient thinks. And they are free to hit that spam button as much or as little as they want to. And that's what the ISPs listen to. Bounces. So we've got hard bounces. Don't deliver this again. Mailbox doesn't exist. Domain doesn't exist. Done. Permanent failure. You've got soft bounces, which are, well, mailbox is full right now, try again in a few hours. There's gray listing, transient network issue, the ISP is overloaded or whatever. And so your MTA is going to have to know whether you're receiving a hard bounce or a soft bounce, asynchronous, synchronous bounce, what it needs to do to retry that message in the future, or not retry in the case of a hard bounce. Content filters. This is a way that ISPs have really tried to become proactive without putting content in front of customers or recipients and saying, hey, you tell me if this is spam. They're trying to be proactive about saying, this actually looks like spam, so we're not going to deliver it at all. And so you see a lot of times with particular types of content that go around, with cut whale, which happened a year or two ago, other spam bot rings around the world. There are fingerprints that are associated with the particular types of email. 10 years ago, you never used punctuation in the subject line. You didn't capitalize words. You didn't use certain pharmaceutical terms in your email, otherwise it would go straight to the spam folder. Now, the content filters have gotten a lot smarter, and so they're looking for fingerprints that they've seen in other areas in the world. You might have seen some of the emails that have come through sometimes where it's just a mishmash of random words that are thrown together, and there's no call to action, there's no link to click, it's just random words that don't make any sense. Well, those are spammers trying to figure out where the limits are on the content filters. And if messages are getting through, then they know what combination of words will work, throw in a link, and bam, it goes to the inbox, someone buys something, and they make money. IP reputation. So we talked about IP seasoning. This is when you get started sending email. IP reputation is ensuring that over time you can continue sending email. Again, over time, good messages going out, not collecting a lot of demerit marks at the ISP, your IP is going to have higher throughput than it would if, let's say, all of a sudden your IP was hijacked. Someone exploited it and started sending a spam campaign through it. There's domain reputation, which is relatively new. It is the ISP's, the email ecosystem's way of responding to IPv6. IPv4, there were a certain limited number of IPs that they could track and keep reputation assigned to. IPv6, they just can't do it anymore. So some ISPs have moved over to IPv6. Most of them haven't. But domain reputation is their answer to this. We're not going to look at IPs anymore. We're going to look at who's sending the mail. And we don't care about what IP it's being sent from. That's where DKIM comes into play as well. SPF, Sender Policy Framework. This is a path-based authentication protocol. And this says when you send a message off to a receiver, the receiver says, what IP address have I received this from? It looks up the domain DNS behind that. It sees if there's a special SPF record in place, which then says, yes, this IP can send on my behalf. Otherwise, it might be spoofed. Sender ID is kind of an add-on to SPF that Microsoft came out with, where they're looking at the PRA, or the purported return address. And so they're looking at the from domain of a message that you send out. And then there are feedback loops. So this is where ISPs who have these programs set up, AOL, Yahoo, there are a few others out there, will let you know when your recipients complain about a message. So it's very handy. And you get enough complaints, obviously IP reputation tanks, deliverability goes down, it all works nicely together. There's a whole bunch more, but hopefully you get the point here. If you're running your own email program, you're going to have to figure out all of this stuff on your own, or pay someone else a moderate amount of money to come in and potentially help you, or you can use Amazon SES. In Amazon SES, we help you fix this situation where you don't have to spin up these efforts yourself. We take care of the undifferentiated muck of sending email. And you also get to really ask yourself, is your email important, right? And so you're not spending all your time worrying about getting the infrastructure set up. You're focused on what you're actually sending your recipients. 183 billion spam messages are sent every single day. I don't know about you, but I haven't seen a huge uptick in my inbox over the last couple of years at the rate of spam that I'm seeing on a daily basis, right? So a couple of years ago, well, let's say 6, 7 years ago, my inbox was just flooded with spam. Last 3 or 4 years, I haven't seen that much additional spam hitting my inbox. Of course, I'll have some come here and there, but for the most part, it's pretty even. But what this means is a whole bunch of stuff going on behind the scenes that the ISPs are doing to make sure that spam is kept out of the inbox, so it's kind of a silent success. Amazon Simple Email Service is a high outbound, highly scalable, cost-effective email sending solution. And so what that means is you only pay for the email that you send. This robust sending platform based on the same technology that Amazon Retail uses to communicate with its millions of customers around the world. My deliverability team, which handles Amazon.com, also handles SES, so you get the same sort of expertise, ISP relations, mitigation assistance there. No email infrastructure, so it's all in the cloud. As long as you can transmit bits of data off to Amazon SES, just like you would any other service in AWS, that's where your responsibility in terms of actually sending the mail stops. And then you can quickly scale your sending. In practically minutes, you can go from 0 to however many you want, depending on whatever your business requires. So let's talk about how email works with Amazon SES, right? So happy path here is you send bits of data off to Amazon SES from to the message body, any headers you might have. We take all that, we put together a nice RFC-compliant envelope and message, and we send it off to the ISP. The ISP accepts it, the recipient sees it, and all is good in the world. Bounces, on the other hand, you send the information off to Amazon SES via SMTP, API, however you invoke the service. We then send that message off to the ISP. The ISP says, hey, this mailbox doesn't exist. Or the DNS server comes back and says, this is a defunct domain. There's no MX record behind it. There's no way for me to possibly communicate with an email server because one doesn't exist. Sends the bounce back to Amazon SES, and then we relay that bounce back to you. So you will always have a hard bounce whenever one is generated from your email sending through SES. And then complaints. Again, you send off the bits of data to Amazon SES. We send that message off to the ISPs. It's delivered So that's a very important distinction here. And then the recipient marks it as spam, right? So you can't have a complaint when someone hasn't looked at your message because they haven't been able to mark the spam button. But if they marked it as spam and the ISP is enrolled in a feedback loop with Amazon SES, we will in turn get that complaint and we will forward that along to you as well. And we recommend here, every time you get a bounce, a hard bounce, and every time you get a complaint, that you don't send to that email address again. Reason why, bounces, ISPs look at senders who generate a lot of repeat bounces as being spammy. Why? Because that's what spammers do. Spammers don't care who they're sending to. They will put every possible alphanumeric combination in the local part, before the @ symbol, and blast it off. They will infect private networks. They will host their own weird data centers at different parts of the world. They send and forget. They don't go through and clean their lists. So an ISP, if they see a lot of bounces coming through, that's indicative to them that you haven't taken the due diligence to actually stop hammering their network with addresses that are never going to have mail delivered. Complaints, the same way. Spammers don't care who's getting a complaint. Their whole point is to send as many messages as possible, and the fraction that convert on those messages actually make them enough money to justify the operation. So if you get a lot of complaints, the ISP is going to push back and consider your mail to be low quality. But we provide both of those to you. It's complaints and bounces. You'll always have those. So let's talk about some features of Amazon SES. You can connect to us via SMTP, Simple Mail Transfer Protocol. This is a very established protocol. Most applications nowadays just speak SMTP right out of the box, simple username, password combination, and away you go. With SES, you simply go in and create your own special SMTP credentials. You can do it through the management console. We have an IAM section, and it allows you not to pass your actual AWS credentials over the wire when you're sending SMTP. So for whatever reason they get compromised, you can just go create new credentials. We have bounces and complaints via Amazon Simple Notification Service. So this is really exciting because up to this point, every bounce or complaint message that we would get, Amazon SES would get, we would just send to you via email. And then we noticed that some of the ISPs were out there saying, hey, all of these messages are coming into this mailbox that are all bounces, or they're all complained about content, and so it all looks like it might be low quality. And so we decided to launch this as a way so you could programmatically get it every single event without having to deal with email at all. You plug into an SNS topic, and every time a new bounce or complaint comes through, it gets propagated to that, and away you go. And Rohan's going to discuss a little bit about that in a second when he goes through the live demo. Mailbox Simulator. This is a great way for you to test what an ISP might do with your mail without actually having to do the bad stuff that spammers do. Right? So if you want to make sure that you have a system that's robust enough to figure out how to handle a bounce, but you don't want to start making up email addresses and sending to them at random, if you want to figure out what a complaint would look like without actually sending low-quality mail to see if somebody complains about it, you can send to the Mailbox Simulator. And we have a success endpoint, bounce endpoint, complaint endpoint, out-of-office endpoint, and a few others. It's all in our documentation. This is also a great way to load test against the service to make sure you're hitting as high of a TPS limit as you can. Easy DKIM, we talked about that a second ago. DKIM is becoming the de facto authentication protocol for cryptographic signatures. It's kind of tricky to implement if you don't know exactly what's going on. We made it simple. So you just flip a bit in the console or via the API. We'll sign the messages on your behalf. All you have to do is throw some CNAME records up into your zone, and you're done. If you use Route 53, you just click a button, and that's it. So super simple integration, and you're compliant. And then finally, domain verification. If any of you have used Amazon SES, you're probably aware of what the verified identities concept is. We have determined that it's we're fanatical about protecting people's mail streams and ensuring that only you can send from yourself, right? And the best way that we found to do this is to say, well, if you're going to send from foo.com, you either own test@foo.com, the email address, or you own that entire domain. But that way, you can't send on behalf of you as another Amazon SES customer and vice versa. So domain verification allows you to stick some text records in your DNS. We poll your DNS. If we find them there, we're like, you own the domain. And then you can send from any address that you want to on that domain, so anything in the local part. Pricing, we have a free tier. We're super excited about that. 2,000 messages a day for free if you send from EC2. If you send from one of their micro instances or something that falls in the EC2 free tier, you could actually be sending email completely for free if you don't send over 2,000 messages a day. So that's pretty enticing. If you are actually paying for the service, we have a CPM model, and this is pretty standard in the industry. It goes back to the days of print catalogs. But CPM means cost per 1,000. So for every 1,000 messages that you send, we will charge 10 cents. We have attachment support within SES. So if you need to send PDFs or Word docs or text files or images, we have a whole list of approved attachment types enumerated in our tech documentation. You can. We charge 12 cents per gigabyte. And that said, chances are you shouldn't be sending a whole lot of big files in email. You should probably be pushing them off somewhere else, linked to a site where the file is stored. And then data transfer fees. This should look very familiar, the same thing that we have in all the other AWS services. With that, I'm going to invite one of my esteemed colleagues up to the stage. This is James LaPlane, Vice President of Technology Operations at AOL, and he's going to discuss his perspective on email. Thank you.
So thanks, Chris. Excited to be here, part of the first user conference. So I thought I would talk a little bit about AOL's spam definition, and then also a little bit about what we recommend as sender best practices. Before I do that, I wanted to take you back a little bit to 1937 in Austin, Minnesota. Hormel invented a lunch meat product called Spam, delivered in a tin can. Spiced ham is what it actually stood for. This is interesting because Hormel credits this as the meat that saved the battle for Europe in World War II, serving up to 15 million cans of Spam a week to the Allied forces as they fought for Europe in World War II. By 1959, they'd sold 1 billion tins of Spam, and by 1970, 2 billion tins. And why is that relevant? Well, it's relevant because it's actually part of Americana. It became an icon. So in December of 1970, Monty Python created a skit with Spam prevalent on a menu in a diner. Mrs. Bunn tried to order something in the diner that didn't have Spam on it, much to the chagrin of the waitress, a party of Vikings, and the rest of the patrons in the diner. Given the audience, I suspect many of you probably have seen this Monty Python skit, and if you haven't, it's a pretty good 3.5 minutes. So this actually became another part of Americana, Monty Python in general, obviously a British comedy troupe, but this skit actually had a pretty big following. And then in 1970s, with MUDs and chats and news groups, people started to refer to excessive messaging, often unwanted messaging, as spam. By the 1980s, with the proliferation of email, this now became the de facto phrase for spam. And ultimately, that's the history. Thought it was kind of interesting to share. Monty Python also has another interesting technology, naming and technology, which is the Python programming language, is named after the comedy troupe as well. So why does AOL care about spam and preventing spam and fighting spam? Well, number one, AOL consumers, or especially our email users, are the most engaged consumers that we have across AOL's properties. You guys are probably familiar with Engadget and TechCrunch and the unofficial Apple weblog and Huffington Post. Well, those are all properties that are under the AOL umbrella and are things that our consumers will ultimately interact with. We send mail, obviously, to those folks, but so do a lot of you and many of the companies we deal with. It's a very expensive proposition for an ISP to support the inbound amount of traffic. As Chris mentioned, 183 billion emails a day, spam emails a day are sent. So that's why it's important to us. I think it's important to you guys because you ultimately want your messages to get to the inbox. So let's talk about that scale. This orange circle represents the billions of emails that are sent inbound daily to AOL email addresses. 88% of them are blocked before they get to the user itself. These are things we can determine are spam already. If I add another 3% to that, which is what actually makes it to the spam folder, we're now blocking basically or foldering 91% of all mail that goes to an AOL.com address. So that leaves a small portion that is into the inbox, that 9% represented, I guess, proportionally there by the green circle. So how do we define spam? Well, we've got a very large consumer-facing email product, and we see the behavior that all of our users, as they indicate things that they think are spam. So these are the definitions that we generally follow. First of all, spam in general is mail that users don't ultimately want. This can be annoyances, pharmaceutical messages, as Chris mentioned earlier. They can also be things that they subscribe to and then they no longer want. Now, many folks may not consider that spam because you actually took the step to sign up for it, but consumers don't necessarily think that way. They're tired of it, they don't want to see it anymore. It's a lot easier for me to hit the spam folder than it is to actually go through the unsubscribe step in many cases. It could also be received through a prior relationship, and then because there's a relationship there, folks say, well, I've already sent mail to you previously, I'll send you new mail, and consumers could respond to that negatively as well. And of course, there's a couple malicious things. They could intend to steal your credentials or to get you to download something installed on your computer, ultimately to probably steal your credentials. And why are the credentials important? Well, it's important because the number one, or one of the larger reasons that people try to compromise accounts is so that they can send spam from known email addresses by taking your address book or by sending from an address that may have a better reputation. So this kind of represents AOL's anti-spam ecosystem, and I can't go into too much detail here because generally we don't talk about how these things work, but what I did want to share with you is we've got some homegrown portions of our anti-spam system. We also partner with other major email providers. We share information about reputation. We share information about blacklisting. It's a healthy community. And then we also subscribe to third parties, denoted here by the centralized external dependencies, things like blacklists, bad content, domain reputations, and even a list of bad URLs. So what are the sender best practices? Well, you can send email from a consistent, identifiable email address. You can also let users unsubscribe. Tell them how to subscribe and how often they're going to see mail from you. Mail should be very easily branded and identified. There's an awful lot of complaints that come in that people don't realize are actually from legitimate places. And that may be just because of the branding. You can also set up feedback loops, as Chris mentioned. And I can't stress these enough because this will really help you determine the types of mail that you send and how people react to those. It may just be simple wording in your message itself that will have different responses. And if you're consistently looking at your feedback reports, you'll know when the type of wording or language or links may be actually damaging the reputation with your consumers. And then remove folks that are sending spam from your email list. Take them off of the distribution. As I mentioned, you should honor unsubscribe requests and maybe even include that in a consistent way. A lot of folks include this in the message footer so that it's there every time, so people don't have to hunt to find unsubscribe. If you make unsubscribing difficult, they won't unsubscribe and they'll just continue to spam folder you. Set up both SPF and DKIM. This is a way for us to build a better reputation about you as you send email to an ISP. And I'd encourage you to do that. There's also another portion that's important. If you are going to sign all of your mails, you should really look into using DMARC. This is really the explicit way for you to tell us that you intend to sign all mail. And if we receive a message that's not signed, we can throw it away. Certain businesses are really good at this. Financial institutions will generally want to protect their integrity and say, we're going to sign all messages with DMARC. That way, if we receive a message from a banking institution that uses DMARC, and it's not signed, we know that this is probably fraudulent. Of course, it could happen where they forget to sign a message. It comes through a different path. But they would be OK with that generally, to throw away a marketing message or something, because they really want the integrity of that mail to be persistent. So we also took a look at some statistics from SES as they send to AOL.com addresses. I'm happy to report these are generally very low compared to other senders in the industry in general. A very low number of invalid addresses. Oops. A very low number of spam complaints, and also detected spam. And generally, we think this is because AWS follows those recommended best practices that I just stepped you through. So that's it for and I want to bring up Rohan, and he'll talk a little bit about the features and show you a few demos.
So, hi everyone. My name's Rohan Deshpande. I am an engineer on the SES team, and I work with the rest of the engineers building some of these awesome features that we love for you guys to use. Let's talk about SES for a second. So, Chris and James gave you a really good introduction on what email is and how ISPs see email that goes through SES or through any other system. I'm going to talk about how you can actually take an application, configure it to use SES, and send email through it, and also handle feedback coming from ISPs. So what does a typical application look like? What does the architecture for an application look like that's sending email through SES? Well, the application submits email to SES either through an HTTP API or through the SMTP API or the SMTP endpoint. SES requires an authenticated encrypted connection, which means you need to get a username and a password. So with the HTTP API, it's your AWS account credentials or your IAM credentials. With SMTP, we generate a special IAM user with distinct credentials from your AWS credentials, and you need to use those to talk through SES. When you submit a message to SES, if the message is accepted successfully, you will get back a message ID. If you don't get this message ID, that means SES did not accept the message. It failed for multiple reasons. For example, the address you're sending to may be blacklisted, or the message did not meet some common format or standard. Once SES accepts this message, it will do some kind of internal processing on it, and it will hand it off to an ISP. Now, what happens when a message gets to an ISP? If you're in the 9% that James was talking about, it will make it to the inbox. If you're not, the message may bounce, or if the message made it to the inbox, the recipient might mark it as spam, and you might get a complaint message back. What SES will do in this case is we will forward that feedback to you, either through email, or if you use the Amazon SNS feedback notification feature that Chris talked about, you can get programmatic access to your bounces and complaints. So that's, in a nutshell, a very simple architecture for using SES with your application. Now, let's actually take an existing application that I have and convert it to using SES in the next few minutes. So there are 3 steps to converting an existing application to SES. Step 1, you need to verify your identity, which in this case could be an email address or a domain. Step 2 is you need to get the right credentials. So if you're using SMTP, you need to get SMTP credentials. If you're using HTTP, you need to get AWS credentials, and preferably use an IAM user to access it. And finally, once you've got SES set up, configure your application, and you're good to go. It's 3 simple steps. You do it once, and your application is set up, and you can start sending email now. So let me actually switch over to all right. So this is a blog I have running out on EC2. This blog is running WordPress, which many of you might be familiar with. It's open source software that you can use to run your own blog, and you can even run it on EC2 like I'm doing. WordPress has a feature where if someone posts a comment, you can get an email notification about that comment, and then you as the administrator can act on it. So what would it take to configure WordPress to send email through SES? Let's start with the SES console. So before I get started, I have an AWS account. I have access to SES. You need to take care of those 2 steps before you can move on with anything I'm showing you from now on. So step 1 is to verify an identity, which in this case, I'm going to verify my domain. So you go to Verified Senders, click Domains, and I click Verify a New Domain. Type in my domain name. And down here, we see a checkbox to generate DKIM settings. If you've ever set up DKIM, you probably remember how complicated the process can be. SES makes it really easy. All you have to do is check this box, and SES will create DKIM records for you, which you go ahead and add to your DNS records. DKIM, for those of you that don't know, stands for Domain Keys Identified Mail. It is an industry standard for associating your email with your domain, and it uses cryptographic authentication. DKIM signed email has a DKIM header in the message, and recipients can use this header to verify that the email actually came from you, from the person who is saying, who DKIM signed the message. So click Verify this domain, and SES will present you with 2 sets of DNS records. The first set is the domain verification record set, SES uses this to verify that you actually own a domain. The second set is a DKIM record set, and SES will use these DKIM records to sign email on your behalf. Here we see one more feature that SES has. Since SES is an AWS service, we have integration with other AWS services, in this case, Route 53. Route 53 is AWS's domain name system web service, which is a highly scalable DNS system. You can use this to host your own DNS records, just like you do with any other ISP. Since SES has detected that my domain is hosted in Route 53, it presents me with this Use Route 53 option. And when I click the button, it will add these records to my Route 53 record set. So on the screen, we confirm that, yes, I want to add my domain verification records and my DKIM records to my Route 53. And I click Create Record Sets. And that's it. If your domain was not hosted in Route 53, you would have to add those records manually to your ISP's DNS using their control panel or console. So domain verification can take up to 72 hours just because of the nature of DNS. Since I knew I was doing this demo, I went ahead and had my domain verified in advance. Down here, you can see my domain shows as verified. And you can see the text records that I should have added to DNS if I was not using Route 53. Another useful tab is the DKIM settings tab. You can see I have DKIM enabled, which means any email I send through this domain or from any address on this domain will be DKIM signed automatically. All right, so we're done setting up SES. That's all we have to do. Now let's go get some credentials. I will be using SMTP to send email, so I want to get SMTP credentials. Go to the SMTP section and click Create My SMTP Credentials. This will pop up a wizard which creates an IAM user in the back. And it will present you with a unique set of SMTP credentials for this user. This is the only place where you can save these credentials. So make sure you either save them in a text file like I'm doing, or you can download them as a CSV and you can keep the file up somewhere. If you lose these credentials by any chance, just come back, delete the IAM user, or you can go ahead and create a separate IAM user. So click Close Window, and now we're done with SES. Let's go back to WordPress and configure it to send email through SES. Go to the dashboard and the plugins page. So WordPress, you can actually configure SMTP settings by either modifying the core PHP files, or you can take the easy route that I did and just use a plugin. So I'm using an open source plugin called Configure SMTP. Go to the settings page. I have some of the details filled in. So the host would be email-smtp. The port, I am using 587 because I want my email to be encrypted using Start TLS, which is an encryption standard that's part of the SMTP the protocol, and I'm using TLS. I want to use SMTP authentication because I need my SMTP transactions to be authenticated. And then I need to plug in an SMTP username and password, which I generated in the SES console. Let's put that in here. Put that in here, and save the changes. And that's it. WordPress is now configured to send through SES. So let's test it. I'm going to log out. Of course. Go here, and let's leave a comment. OK, so let's go check our inbox and see what we have. So we have a message from WordPress here. Now, how can we tell this message came through SES? Let's take a look at the message headers. All right. So here we see we have a message ID that was added to this message using Amazon SES. SES will actually rewrite any message IDs you have in the original message that you submit to SES. This is because we actually use this message ID to track bounces and messages that go through our system. You can also see that SES added a DKIM signature. Well, right here. That's awesome art. Anyway, so as you can see, SES signed your message, so now any email that goes through SES from your domain will be DKIM signed. And that was it. In 3 simple steps, we've taken an application, and we've configured it to send email through SES. WordPress is now good to go, and any email going forward will go through SES. So wasn't that simple? All right. Now let's move on to the next aspect of being a good email sender: receiving and handling bounces and complaints. When you send an email to an ISP, and if the message bounces or if we get a complaint, the ISP will send back a bounce or complaint notification to SES, and SES will forward that message back to you. If you've ever tried parsing those messages, you'll know it's not a very simple process. Those bounce and complaint messages don't usually have the same format or a common format. And you also need some idea about SMTP response codes so you can parse those messages appropriately. What SES will do is we will take those messages, we will parse them on your behalf, and we will categorize them as permanent or transient bounces. So all you have to do is look at and we'll actually respond back with a well-formatted JSON message. You just look at the JSON message, look at the bounce type, is it permanent or transient? If it's permanent, you typically want to take the recipient off your list. Don't send to people that are marked permanent bounces. If it's transient, you typically want to wait up to 24 to 48 hours before you retry sending to those users. And you can actually get those messages using Amazon SNS or the Simple Notification Service. SNS is a pub sub system for sending and receiving notifications in the cloud. So let's take a look at how we can take a verified domain and configure it to send, or to configure to receive bounce complaint notifications using SNS. So we're back in the SES console. Let's actually start in the SNS console this time. Let's create a new topic. Call it my WordPress feedback. Create topic. And let's subscribe an email address that will receive these notifications. So while I'm doing this, the SNS actually uses double opt-in for verifying that this email address should get email notifications from this topic. And this process is different from what SES has. So once you add an email address, you will get a confirmation message. Click this link to confirm that, yes, you do want notifications on this address. And then go back, refresh, and you can see now the topic is configured to send you bounces and complaints to that email address. Now let's go back to SES, pick our domain. Go to the Feedback Details tab, and you can modify configuration here. So pick a topic. So pick the topic I just created for receiving bounces and also for complaints. This email feedback forwarding option. So if you don't use SNS, you will get the raw email message back with the raw bounce or complaint message in it to your mailbox. Once you're comfortable with receiving SNS, receiving notifications over SNS, you can go ahead and turn this off. The only value it would have is if you ever wanted to archive those raw bounces or complaints for any kind of archival reasons. Let's leave this enabled for now, and we can disable it later. So click Save Config. And that was it. We've got the domain configured to get bounces and complaints through this SNS topic. We need a way to test this. Sending real bounce or generating real bounces or complaints is not ideal because that could impact your sending metrics and also impact your reputation in the eyes of ISPs. So what SES did is we recently released another innovative feature called the Mailbox Simulator. The Mailbox Simulator lets you create bounces or complaints that you can test with without impacting real recipients. So let's use this to see if our configuration is set up right. Click Send an Email. Want to send it to bounce@simulator.amazonscs.com. And this address, when you send in a message to it, will generate a bounce. We have a few more addresses to test out-of-office responses, complaints, just the typical success scenario, and a few more, which are listed in the developer guide. So when you click Send Test Email, this should generate a bounce notification. Let's go back to our inbox. These are subscriptions succeeded, which SNS sends us. And here's the bounce message. Let me point out some parts of this JSON message to you. So here we have the message type is a bounce. The bounce type is permanent. So SES parsed the bounce response and marked it as permanent. It even tells you which email address bounced. So there's, let me point out something else. So there's a message ID. This is the original message ID of the message as it was sent through SES. Now, you can use either this message ID to identify the original message, or you can just use the email address that's part of the bounce message and take it off your list because it's a permanent bounce. And if you want to test complaints, you'll get a similar JSON message. The format is documented in the developer guide, and you can handle complaints a similar way. Typically, if you get a complaint, you want to remove the recipient off your list again. And with that, I wanted to recap what we just demoed. So we looked at configuring bounce and complaint notifications using Amazon SNS. This is SES's way of parsing and simplifying your experience with bounce and complaints. And also, we looked at Mailbox Simulator, which is a great way to test SES and email sending in particular and your application. Some really interesting scenarios are making sure your application can actually handle bounces complaints properly, or you can even do some kind of load test. So just send it to the success address and see if you can hit the maximum TPS, make sure your application can send with the right throughput. And that's all I have. So back to you, Chris. Thank you, everyone.
All right, what about that? We had a live demo that worked. Woohoo! Okay, so let's leave you with some tips here before we end the discussion. 4 quick, easy ways to remember how to get started using SES. The first is submit a production access request form. Go to the site, fill out the form, you put in some very simple information, hit submit, and within sometimes minutes, you're ready to go. Send for free from Amazon EC2, spin up an EC2 instance, send via SMTP, under 2,000 messages a day, completely free. You can send via API or SMTP outside of Amazon EC2 if you wish, from whatever infrastructure or wherever your application is hosted. And then finally, make sure you're looking at your feedback through Amazon SNS, if that's how you want to integrate, or through email. Remember, bounces, complaints, don't send repeat attempts to those same addresses because the ISPs don't like that. We have a whole bunch of different links here, which I don't expect you all to write down furiously. The slides will be available afterwards. But the product detail page, the first link there goes into just a general description of the service. We have a full set of documentation, developer guide, API guide, getting started guide. We have our forum, which is heavily used and participated by many of our customers and staff. We have our own blog. So email is a different beast than some of the other services, and we get that. And so we launched our own blog about 6 months ago. Go there and you can read about email best sending practices, review latest webinars that we've done, get help on technical questions that you might have, any new announcements that we have as well. And finally, we published a white paper which describes soup to nuts how to send good email. Remember, email is a marriage of both policy and technology. And without both of those in a good state, your email will not get delivered to the recipient, wherever that might be. So this white paper just takes you through the entire gamut. That's it. Please be sure to fill out an evaluation form. We're going to be in the booth in AWS Central right after this if you have any questions. Thank you very much for attending. I appreciate your attention, and thanks a lot.